Let's get started. We'll just start with the test. Everyone wants to talk about tests. I'm going to give them back at the end of class. So I use that new system I talked about. It took me a while to figure it out. But I hopefully, so first off, did everyone receive an email saying you got a grade? Okay, no. Oh, yours wasn't graded.
No, when I went there, I later.
Oh, and have you checked that?
Yeah.
Okay, so is that graded?
Yeah.
Okay, now, could you see the test?
Yeah.
Oh, you could, so you could go through and see the grading on it? Okay, so then that's how you're going to get your test. Your actual graded tests are going to be in that online system. And so what it allowed me to do is, like, if I took a half a point off for it and later decided to work a whole point off, or vice versa, I could change it in one person and everyone would get the same grade. So hopefully that worked out well. That's my intent. Okay, so everyone now has access to your test. If you don't, I actually didn't see the email that you guys got. So maybe talk to someone that has had success if you haven't had success. Okay. Let's try that. Let's see, so we're going to be moving on today to new material. And there's one other tidbit I had for you, but I can't remember what it was. That'll probably hit me in the middle, just to let you know have a random side commercial information. So, all right, so let's get started. Today we are going to. Okay. Let me show you. Well, I'll just show you what we've done. So we started out. So we're talking about second order. Second order differential equations. And I could even say second order linear differential, or linear second order differential. And so we began. With what we first solved was m y double prime plus k times y equals 0. That's where we began. And we said that this models a spring that is in a frictionless environment. So this models a spring. And actually what they call it is I'll write it both ways, models a spring. Models a spring in a frictionless environment. So frictionless environment, I'm going to put a comma IE. It's also called an undamped spring. Undamped spring. So, yes.
What is that?
Oh, it stands for, it's Latin for it's est or something like that, something that doesn't make any sense. But it translates to that is. So, it's usually read as that is an undamped spring. So that is. Good question. That is. No, there's not, which is kind of surprising. No, not that I know. There might be, but I haven't seen. so today we're going to extend these. So today, and for tomorrow, and probably the next day. Today, we're going to study damped. Today, damped harmonic motion. Damped harmonic motion. And we write it this way. This is the damped harmonic motion. I'll put a period there. General form. General form. General form is, we write it this way, A, Y, double prime, plus B, Y, whoops, Y, single prime, plus C times Y equals 0. That's what we're going to study. So if we're studying equals 0, what solutions are we finding? Null solutions, right? So we'll be finding, so today we'll be finding null solutions. A little bit more. By prime. By prime is the damping term. And the damping term. So what would be a good example of a damping term? I think I drew the shock absorber for you, right? Did I draw the shock absorber for you guys? I drew it for some. Oh, maybe it's my other class. No, but it was a. I know, right? I'm too tired on you. Let me see if I can do this. It's been a while since I looked under the hood of my car. But you have some big heavy screen. You have these attachments. And it goes like that. Like this. That's your spring, and then of course this is not perfect. If someone in here is a car nut, you can talk to me later. Then you have like the rotors for your brakes. They have brake pads on them, but I'm not going to draw those. And then on top of that is you have your studs to your tire, and then your tire sits on top of that. You know, if you've got a cool pickup truck, like you've got big knobby tires, right? If you've got a race car, you've got big slicks. But this really isn't what we want to see. What we're interested in is the spring. We're interested in the spring. I left out something. What I left out was the shock absorber. And it depends on like older cars, newer cars, and some of them have shock absorbers and some of them have strut assemblies. It doesn't matter, it all gives the same effect. And so maybe you looked at your car and you might have noticed that there's a cylinder inside of your car, inside of the spring itself. And this is not going to win the car show award. This is the idea. So you have this, and they're often blue, like Monroe's shocks are blue. You get red. 2 sets of shocks. So, does anyone know how to test if their shock absorbers are going out on their car? What was that? Drive over some rocks? No, actually, no. What you do is you get on the back of your car and you jump on it and you jump off. And if your shock absorbers are going out, what it means is the car is going to bounce. Like if your car is newer or your shock absorbers are newer, jump on it as hard as you can and jump off. I mean, don't fall. And if you do get hurt, don't sue me. Or have your friend do it. Right? Hey, you want to try something? So what will happen is if your shock absorbers are working, it'll immediately stop the spring. But if I was to erase the shock absorber entirely, and I got on that car and started bouncing, what would happen? Yeah, it would just keep going. So if you ever are driving and you see like someone hit a speed bump and their car just keeps bouncing for a little bit, they need new shock absorbers. Okay? So the shock absorber here is what stops the spring from just endlessly going up and down and up and down. That's this term right here. If it's positive, it's actually damping, meaning it's going to slow the spring down. If you have, and let me write that down. That's good stuff. So let's do this. And we're going to see this too. If B is positive, then the spring is damped. The spring is damped. I'm going to come over here. The spring is damped, comma, and the spring is brought to rest. The spring is brought to rest. Now, next time you take your car to the mechanic, don't try to explain differential equations and shock absorbers to them. They will double what they're going to charge you. Just knowledge has to be used carefully. So that's what we're going to study today. We're going to study all of this. And what's kind of interesting is what we're going to study is that there's a whole variety of cases. And that's what we're going to do. So let's start. We're going to learn by examples. Or not learn, maybe you just begin with it. Learn or introduce it by example. Begin with the example. Yeah, you'll see it. What happens is that you hit that speed bump, and instead of your car doing this, it does this. And then it like flies off the side of the road. That's what would happen. If you have a forced damping, then it's going to be more and more and more. And actually, that we'll come back to this. Begin by examples. So let's do this. Let's let our first one be, okay, don't look. Okay, don't look. I have to think about this for a minute. Okay, you can look. Okay, so you need to here's my example. So the first one we're going to look at is we're going to solve. We're going to solve y double prime plus 4y prime plus 3y equals 0. That's the first one that we're going to solve. I think you know, we're not going to solve it with an integrating factor. We're going to solve it again by undetermined coefficients. So what do you think we should try? Make it easier. What's been the magic function so far? E, right? E, E can be circular, and E can just be exponential like you would expect now. So let's let E be our guide. So we're going to try. So we're going to let E be our guide, or in other words, we're going to try y. I'm going to write the null in the end, but y equal. Let's just write. I'm going to use the same letter. We don't know what S is going to be, but E to the ST. Try y equals E to the ST. Let's see what that has to tell us. So in order to do that, what we need to do is we need to see how this is a solution to our problem. We need to plug y into here. We need to plug y, or we need to substitute y prime in here and y double prime into the double prime term. So take a moment and find y prime and y double. It's going to take care of itself. It's going to take care of it. These are the constants that we're going to have to deal with. So take a moment. I'm going to do it as well. I'm going to see what I come up with. Y prime S E N Y double prime S squared E F. Is that what you guys are coming up with? Y prime is S e to the ST and Y double prime S squared E to the ST. All right, let's substitute those in and see what happens. So this is going to be I'll write our steps. So substitute the solutions. Substitute. We'll put it the hoped as solutions because that's what they are at this point. So I have S squared S squared E to the S T plus I have a 4S E to the X T plus 3 times E to the X T equals 0.